for this short tutorial, we'll be talking about how to find the angle between two lines. If two lines intersect, such as this, and we have to find the angle alpha between these two lines, let's assume that the slope of the first line here is m1 and the slope of the second line is m2. To find the angle alpha, we are going to be looking at the formula, which is tan alpha equals to m2 minus m1 over 1 plus m2 m1. This is just a quick recap of what we are going to be talking about. So we are going to derive this formula. Now let's look at a Cartesian plane. Here we have our Cartesian plane with the y and the x-axis. Let me redraw the x-axis. Okay, we have the x-axis here and we have the y-axis. So I'm going to imagine two lines now that intersect. We have a line here and we have and we have another one here. But to make it more clear, let me redraw the second line. It's not coming out clear. Okay, I think we have a good one here. And this is line A, B, this line CD. So if you are looking for this alpha, which is the angle between these two lines, so we are naming this as alpha 1 and this as alpha 2. This as alpha opposite angle equals, so we have alpha here, we also have alpha here. Just for some easy navigation, let's call this side P and this side R. So we are assuming that the gradient of AB equals to m1 and the gradient of CD equals to m2. Then from the formula we have that tan alpha equals to m1. This is going to be tan alpha 1. You know what, I'll just do this again. Let's rub this off. Let's consider line AB. Line AB makes an angle of alpha 1 with the positive x-axis, so we can get the slope of line AB by considering the formula for looking for gradient, which is tan alpha. Here we have alpha 1, which makes an angle with the positive x-axis. So this tan alpha 1 equals to m1, since we are assuming that the gradient of line AB equals to m1. And also line CD makes an angle of alpha 2 with the positive x-axis, so we can say that tan alpha 2 equals to m2. Also from the rules of triangle, we know that alpha 2 equals to alpha 1 plus alpha. This is the exterior angle of a triangle, and then we are going to have that alpha equals to alpha 2 minus alpha 1. To continue the proof, let's take the tangent of both sides for this particular equation. So now let's take the tangent of both sides. We now have tan alpha equal to tan alpha 2 minus alpha 1. And from trigonometric ratio, if you have tan alpha 2 minus tan alpha 1, this is going to be tan alpha 2 minus tan alpha 1, everything divided by 1 plus tan alpha 2 multiplied by tan alpha 1. This is derived from trigonometric ratio. You can check out our catalog on trigonometric ratio and how we can derive this and how we can prove it. So we are going to have here to be tan alpha 2 is m2 minus tan alpha 1, which is m1, divided by 1 plus m2 m1, and that is the formula for finding the angle between these two points. Let me write that again. If I'm looking for tan angle alpha which is the angle between two lines, this is going to be equal to m2, which is the gradient of the second line, minus m1, gradient of the first line, everything divided by 1 plus m2 m1. This is m2 times m1. Let's look at some examples to illustrate this point. One thing we have to note here is that we are taking the absolute value. So if you have tan alpha, it's going to be the absolute value of m2 minus m1 over 1 plus m2 m1. Please note that we are taking the absolute value of m2 minus m1 over 1 plus m2 m1, so there won't be negative cases. As an example, let's look at this question. Find the angle between lines AB and CD given the coordinates below. We have to find the angle between line AB and line CD. Let's write out our formula again. We know that if you are looking for alpha, which is the line between two, which is the angle between two lines, you're going to have tan alpha to be equal to the absolute value of m2 minus m1 over 1 plus m2 m1. Now we have gotten our formula. So what's the slope of AB and the slope of CD? Let's make m1 to be the slope of AB, and then for AB we have the slope to be equal to y2 minus y1, which is 3 minus 1 over 4 minus 3, and this is 2 over 1, this is 2. The slope of CD to be m2, and this equals to 8 minus 6 over 7 minus 4, and this is 2 divided by 3. Now going back to the question, we're now going to have, let's roll a line, okay, tan alpha to be equal to the absolute value of m2 2 over 3 minus m1, which is 2 over 1 plus 2 over 3 times 2. Here we're going to have tan alpha to be equal to 1. So alpha equal to the tan inverse of 1, and alpha equals to 45. So the angle between these two lines AB and CD equals to 45 degrees. This will be our last example. We have to find the accurate angle between the lines 4y plus 3x equal to 2 and x minus 2y equals to 3. To do this, we are still going to be using our formula, which is tan alpha equal to the absolute value of m2 minus m1 over 1 plus m2 multiplied by m1. So this is the first line and this is the second line. What we need to get now is to get the slope of this line, which is m1, and the slope of the second, which is m2. To get this, we are going to be using the general equation of a straight line, which is the first was y equal to mx plus c. This is the formula for representing the general equation of a straight line, where m is the gradient and c is the intercept on the y-axis. So to compare the first equation with the general equation of a straight line, we have the first equation to be 4y plus 3x equal to 2. We are going to write this now in form of the general equation. We now have y equal to minus 3x plus 2 over 4 over 4. Therefore, we have m to be equal to negative 3 over 4. We get this by relating the two equations after we already divided everything through by 4. So y equal to y minus 3 over 4x equal to mx, c equal to 2 over 4. For the second part of the equation, we have x minus 2y equal to 3. And to write this in form of the general equation, we have x minus 3 equal to 2y. Dividing through by 2, we have y equal to x over 2 minus 3 over 2. Here we have m, this is m1, we have m2 to be equal to 1 over 2. We now have our m1 and m2. Going back to the formula, to get alpha, we have tan alpha equal to, now m2 is 1/2 minus -3/4. Everything divided by 1 plus 1/2 multiplied by -3/4. So here we have tan alpha equals to 2, and alpha equal to the tan inverse of 2. Here alpha equal to 63.43 degrees. And this is how to find the equation to find the angle between two lines, whereby we are given the equations of the lines.